So in this today's class, we are talking about some examples how we are going to perform the AVL rotations. Either it may be LL rotation, RR rotation, or LR, RL. Any one of the rotation from four types on AVL trace. So let's start the example. So look at the first tree. This is binary tree because every node having either 0, 1 or 2 childs only. That's why it's a um, binary search tree. Okay. So now how when we are going to perform the LL rotation. So basically this is the previous tree. Okay. Now I'm going to say that insertion, deletion, and the search operations on AVL tree. Okay, so once you insert an element or an node into the given tree, so every time you have to search the balance factor. So what is mean by a balance factor? Means balance factor. It may be a remember this is very important point. Balance factor is equal to either 0 or 1 or minus 1. If you are not getting except these three numbers, if you are getting another number, then you can say that the tree is unbalanced tree. So at that time you have to do the rotations based on the type. You have to apply the any one of the rotation. Now let's look at this example. So this is the given tree. Okay, how many nodes are present in this tree? Totally 5 nodes. Fine. Now I want to insert node 10. So if I want to insert node 10, where I can able to place in this given tree, because I have to compare with the root node first. So 10 is compared with the 10 is compared with the root node 50. So 10 is less than root node, less than root node. Okay, our new node means our element, that is 10, is less than the root node. Whenever it is less than, which side of tree we have to go? We means we have to go left side, because our new element 10 is less than the root node. That's why we have to move left side, because according to the principle of binary search tree, all the nodes present at the left side should be less than the root node. That's why we are moving left side. Okay, fine. Next, our element is 10, no? Now compare with the 30. So 30 is present. So again our element is less than 30, means which side we have to go? Either right or left? Again left only. Why? Because our element is 10 is less than the node, that is 30. That's why we are moving left side. Again we have a node number, that is 20 is there. Okay, now again compare our new element with that node. Again 10 is less than the 20. So whenever it is less than the 20, which side we have to insert? Which side we have to go? Either left or right. It means here left only we have to move. Why? Because our element, that is 10 is 10 is less than the 50, less than the 30, less than the 20. That's why we are moving only left side. Okay, so 20 doesn't have any left or right child, so that's why we are moving at the left side. There we are going to insert our new element, that is 10. Okay, that is 10. Now let's look at the resultant tree. See, where we inserted 10 here. Why we inserted 10 here? Because we followed the binary search tree principle. What is the binary search tree principle? We are following all the right side subtree have values are greater than the root node. All the left subtree values are less than the root node. That's why According to that principle, we inserted our 10 here. Okay. Now you have to check the balance factor. Okay, so once you check the balance factor, if it is balanced, then it's okay. If not, you have to rotate it. So let's check the balance factor. How to check the balance factor? For every node you have to find out the balance factor. Okay, so for 10, so is there any right child or left child? Nothing is there. So 0 minus 0, it is 0 only. Now again, what is the balance factor for 20? Here there is no right node, no right child. Okay, there is no right child, means 0. Again we have one left child. So 0 minus 1, what is the value? Minus, here we will get minus 1. Fine. Again, what is the balance factor for 40? So remember, for every leaf node, the balance factor is default. It is equal to 0. Remember that one. Because there is no right shell, there is no left shell. That's why we got 0 here. Now, what is the balance factor for 30? How to find the balance factor? So how means height of the right subtree minus height of the left subtree. That is the balance factor. Okay. Now how many nodes are present at the right side first? Only one node. So 1 minus how many nodes are present at the left side of the 30? 2. So 1 minus 2, 1 minus 2 is minus 1. That's it, no? 1 minus 2 is minus 1. Fine. Now what is the balance factor for 70? As it doesn't have any right child or a left child. So the balance factor of 70 is 0. Okay, now what is the balance factor of 50? Let's check how many right childs are there. What is the balance factor of right subtree? 0. Sorry, 1. Okay, so one right child. So that's why 1 minus. So how many? What is the height of the? What is this left subtree? So 3. Right. So 1 minus 3 is minus 2. Minus 2. So whenever we are getting except of 0, minus 1 or plus 1. Okay. So 1 minus 3 is minus 2. No. So except 0, minus 1, plus 1. If you are getting any number as a balance factor, then we can say that it is this tree is imbalanced tree. Imbalance. This tree is imbalanced tree. Now it's our duty that we have to balance it. How we are going to balance it? Based on the rotations, based on the 4 types of rotations, based on the leaf nodes, at which side they are heavy. Based on that, you have to select the which type of rotation you have to apply. Now let's look here. So now which rotation we have to apply? In a single right rotation. Single right rotation means we have to move the nodes at right side. Okay, right side we have to move. Whenever we move the right side means this side. We have to. So which side the nodes are more? Left side. We if we want to balance this AVL tree, we have to move some nodes from left to right. That's why right rotation. Okay, that's why right rotation. How to move the right rotation? So on which side? Here 30, we have to move 30 to the root node. So when 30 will becomes as a root node, remember, based on this figure, 30 becomes the root node. Okay, so 40, actually 40 is present at the left side. Why? Because based on the root node, 40 is the less than the root node. That's why it is present this side. If 30 becomes a root node, now where the 40 goes? At right side. That's why, so when 30 becomes as a root node, so 40 will comes at the right side. Right at right side also, where it has to place, so where means, so it is less than the 50. That's why it is acts as the left node of 50, left node of 50. So this rotation is called right rotation. Okay, this rotation is called right rotation. Why we call it as a LL rotation means whenever it when the left side heavy, left LL rotation. Why we call it as a LL rotation means left is child, left side heavy. So when left side nodes are heavy, then we have to apply the right rotation to balance this imbalanced tree. Now if you check this balance factor for every node, it is either 0 or 1 or -1 only. So that's why, so it is this is called as a balancing tree. Okay, balancing. So now what happened here? So child, so left child becomes as a parent. Now parent will becomes as a right side. Okay, right subtree node. So like this we are going to balance the tree. So this is one of the example for which type of rotation, LL rotation. Now let's look one of the another example. So today in today's class I may say 4 or 5 examples. Okay, so RR rotation. Now look at this picture. Why I'm saying this is RR rotation? Right side, right child, right heavy means all the nodes are right side only, right side childs only more than compared to the left side. That's why this tree, okay, this tree is not is belongs to RR rotation. This tree belongs to RR rotation. This is also unbalanced tree. How we can say that it is an imbalance? Let's check the balance factor for each and every node. Okay, I already said that each leaf node having a balance factor as 0. Here 20 is a 0, 20 balance factor is 0. For 70 also 0, even for 95 also 0. Okay, now calculate the balance factor for 90. So right subtree minus left subtree. How many nodes present at the right subtree? Only one. So 1 minus, how many nodes present at the left subtree? 0. 1 minus 0 is equal to 1. This is the balance factor for 90. Now what is the balance factor for 80? Now again count how many nodes present at the here not number of nodes you have to count, level of the nodes, how many level of the nodes you have to count. Okay, so here 2. So in this level one node, in this level second node, I mean another node. So totally here 2 nodes are present. 2 minus at the left side 1 node, 2 minus 1 is again 1. So here there is no problem because the balance factor we got is up to now 0 1 1 0. So no problem. Now what is the balance factor of 50? Now what is the balance factor of 50? Now how many nodes present at the right side? How many nodes means you don't take it as a 4. How to calculate means like this you have to calculate. This is level 1, this is level 2, this is level 3. Based on the height of the nodes you have to take. So how many nodes totally? 1, 2, 3. Okay, so 3 minus, so at right side, right subtree we have 3 levels of nodes. Okay, 3 levels of nodes. Now minus, how many nodes are present at the left side? Only 1. So 3 minus 1 is 2. So 2 is the balance factor of 50. That is root node. So here whenever we are getting 2 is the balance factor, this tree is belongs to RR rotation. Okay, so whenever you are getting the balance factor of root node is 2, not only root node, if you are getting 2 as a balance factor, then it is belongs to a rotation, that is RR rotation. So whenever RR rotation comes, so this is a imbalanced tree. Now it's your duty that you have to make it as a balance. How to make it as a balance? You have to apply any one of the rotation. Now let's check what is the rotation we have to do. Just now I explained. So this is the factors we are getting. Okay, so whenever we are getting this +2 and the +1, then we it is belongs to a RR rotation. Okay, now we have to, so after balancing means how to balance this one. So we have to rotate RR. No, this is belongs to RR, means rotate right side nodes, rotate rotate. Okay, RR means rotate the right side nodes, right side chails. Okay, now if you rotate right side chails, 80 will become as a parent. So 80 become as a parent, so 80 comes here. Let's see here, 80 comes here, this is the root node. So when 80 comes here, 50 goes left side, 50 goes left side, 20 is also left side. Now, according to this picture, actually, see here, 80 goes here. 80 goes as a root node. Now 50 will goes down, means left child of 80. If 80 is the root node, okay, listen carefully, 80 is the root node, then the nodes present at the right side must be greater than the 80. But at that time, 70 should not present at the right side. That's why the 70 node is also goes to the left side. Are you getting my point? If 80 is the root node, 70 should not present at the right side. Okay, why? Because 70 is less than the 80, no? That's why it has to move to the left side. So in left side also, where it has to place right of the 50. Are you getting my point? When 80 becomes a root node, okay. So in previous 50 is the root node. So 50 becomes a left child. 50 becomes a left child. Now 70. So where we have to insert a 70, we have to check with the root node first. 70 is less than the 80. So move to the left side. So now compare with the 50. 70 is the greater than the 50. That's why move to the right. So there we have to insert. Now again you have to every time you have to calculate the balance factor. Okay, so what is the balance factor for 20, 70 and 95? 0 only. Now what is the balance factor of a 50? I mean right subtree minus left subtree. So 1 minus 1 is 0. Again what about this 90? 1 minus 0. Again we are getting here 1. 1 minus 0 is 1. Now what about 80? So how many nodes present at the right side? 1, 2. So 2 minus. So how many levels of nodes present at the left side? Or 2 only. So 2 minus 2 is 0. So when we get the 0, 1 minus 1, then we can say that the tree is is balancing tree. That's why. So AVL concept, mainly AVL concept is used to balance the tree. Why we are going to balance the tree always? If it is not balanced, what will happen? What will happen in the sense, I will say later in the next traversal, next operation. Okay, so this is one more example. There are 5 more examples are there. I will explain this example later. Remaining 2 examples, you just go for it. Okay, now I'm taking some 5 what is this elements. Okay, 50, 70, 30, 40, 20. So like this, yeah, I will give some example. You just take some random numbers. Okay, according to the principle of binary search tree, you just what is this, establish the prepare the construct the tree. Okay, so the first element is always the root node. That's why 50 is the root node. Now 70 is compare with the root node. It is greater than the 50. That's why move to the right side and insert here. Now what is the next one? 30. Compare with the root node. 30 is the less than the 50. That's why move to the left side and insert here. Now what is the element? 40. Now compare with the 50. It is less than. Move to the left. Now already 30 is there in previously. Okay. Now compare 40 with the 30. So 40 is greater than. That's why when it is greater, which side we have to move? Right side. So insert here. Now what is the last element? 20. So now again compare. Always you have to compare with the root node onwards. Okay. So compare with the root node. 20 with 50. 20 is less than. So move to less. When it is less than, left side you have to move. 30. Compare with the 30. 20 with 30. Again it is less than. 20 is less than the 30. Move to the left side. Here you are going to insert. Now it is this is nothing but a binary search tree. Now I want to insert 10. Now I want to insert 10 to this previous tree. Okay. When I want to insert 10 to the previous tree, where it is possible to insert, so it will compare with 50, 30, and then 20. So after 20, our 10 new element is less than the 20. So it will come left side. So whenever it is inserted left side, then again after calculating the balance factor of each node, then we are getting the -2. So whenever we are getting the -2 as the balance factor, then we can conclude that this tree is imbalanced tree. Now it's our duty that we have to make it as a balanced tree. So how to do? Which side the nodes more children are present? Left side. So if all nodes present at the left side, we have to move some nodes to the right side. That's why right rotation we have to do. Are you getting my point? Wherever the nodes are present more, opposite direction we have to move to balance the tree. Now if you move like this, single right rotation is required. When you do single right rotation, what will happen means 30 becomes the root node, means this one. This goes here. Okay. When 30 goes here, I already said when 30 goes here, so when it becomes 30 is the root node, then what are the nodes present here? 20, 10, 40. 20, 10 are the less than the 30. What about 40? It is greater. So it must present at the right side. Now look at the resultant picture. This is the resultant picture. Okay. Now 40 will goes right side. Why? Because when 30 becomes as a root node, okay, our 40 in previous, where is the 40? Here. Okay. When 30 goes here, 50 also goes right side. Why? Because 50 is greater than the 30. Now where we have to place 40 means it is greater than the root node, again less than the 50. That's why it is placing left side of 50. So like this, we are going to insert any number of nodes in a given tree. So remember only one point. Whenever you are adding a new element into the tree, every time you have to calculate the balance factor. Whenever it is imbalance, you have to make it as a balance. How means based on you have to apply either LR, RR, or LL, RR. So any one of the rotation you have to apply and make it as a balance. Now the balance factor is 0. Now you can say that it is a balanced tree. Again, three more examples are there. You please go for it. Now I will start the deletion operation directly. Yes. Now this is the deletion. So this is the tree. Now I want to delete 30, node number 30. Where is 30? Here 30 is there. If you want to delete 30, How first you have to check the deleted node having one child or two child, or it is a leaf node. So check that one. So here 30, if you want to delete 30, then check how many childs it has. Two childs. Whenever it has a two childs, then what should you do means replace the node, means whatever the node we want to delete, replace with highest value in the left subtree, highest value in the left subtree. So after 30, what are the nodes present? 10, 20, 40, 45. Which one is the highest one at the left subtree? 45. Now replace with the 30. Now it will become so. So after deleting 30, 45 goes, see here. Not here, highest, smallest. Okay. So smallest one is 20. So 20 goes, 20 will be replaced with the 30, and then delete the 30 node. Now again you have remaining the resultant tree is looks like this. So you have to check again the balance factor of each and every node. Okay, each and every node. So once if it is in balance, again you have to apply the rotations. So again I'm going to repeating. So if you want to delete leaf node, if you want to delete any leaf node, directly you can delete. Okay, directly you can delete. If you want to delete, for example, 55, for example 55, which is having only one child, okay, then replace that one child with that node. Then you have to, I mean, swap like this. 55 comes here, 60 goes here. Okay, then delete the 55. When the node having a two children, when the node having a two children, then you have to choose, you have to pick the smallest one at the left side, greatest number at the right side. If you are deleting 65, then you choose the greatest number. If you are deleting 30, then choose the smallest one. Based on the left subtree or right subtree, you have to choose the either greatest or smallest. Replace with that and then just delete it. Later you have to check the balance, I mean a balance factor for each node. Okay, now again one more example here. So delete, if you want to delete 10, if you want to delete 10, so simply 10 is a, so 10 is a leaf node. Okay, 10 is a leaf node, directly you can delete. So what I'm saying is after deleting, you just find the balance factor again. So once you find the balance factor, okay, balance factor, so it will get imbalance only. Why? Because see here, right child of 20, right child of 20. If you delete this one, what is the balance factor of 20? So 1, 2. So 2 minus 0. 2 minus 0 is 2. Means once you deleted 10 here, the balance factor of 20 is 2. So 2 is, whenever you are getting a balance factor is 2, then it is imbalanced tree. Now you have to rotate. Which one you have to rotate? Which side nodes are more? Right side. That's why you have to, when right side nodes are more, you have to make it, I mean, rotate to left side to make it as a balance. At that time, what will happen? See, apply the RL rotation. Then what will happen means, see this one I just now I said after deleting 10, the balance factor for 20 is 2. Now you have to make it as a balance one. How to make it as a balance one? Here you are getting a problem. Here you are getting a problem. To remove that one, so whatever the least element here, okay, that should become as a root node. And then whatever this 20 will become as a left child, and whatever the node present, that is become as a right child. Now again you just calculate the balance factor of this tree, then it will be in balance only. So So whenever you want to delete, you have to check the balance factor. Once it is balanced, no problem. If not, you have to make it as a balance by applying any one of the rotation method. Now again delete 50. Delete 50 in the sense complete root node. Whenever you are trying to delete a root node, so either you can choose the greatest number here, the greatest number at the left side, or smallest number at the right side. You can replace any one of the node and make it as a balance. So after deleting this one, after deleting root node 50, so either you choose from left subtree or right subtree. Okay, if you are choosing right subtree, choose the less number. If you are choosing the left subtree, then choose the greatest number and replace with the root node, then delete your particular node. After deleting 50, it is in balance only, so no need to apply any rotation method. So this is the deletion operation. And the last operation, that is search. So search is a very, very simple concept. So whenever you want to search any node in the given AVL tree, once it is found, you just print a message that is element is found according to the conditions. If it is not found, then you just print a message that is element is not found. For example, how the search method will be works means, for example, I want to search 75. So whenever you want to search any number in the given AVL tree, okay, based on the root node, if your search number is greater than, then right subtree only, it will search only right subtree. Okay, if I selected 20, first it will compare with the root node. So our element is less than the root node. Then at that time it completely skip the right subtree and start the only search at the left subtree only. So based on that binary search tree concept only, here it will follows. Okay, based on that only it will search. Once it is found, the element is found will be print on the monitor. If not, no element will be found. Okay, these are the three operations we can perform on the AVL tree. One is insertion, next deletion, and then search. So these are the three operations we can perform on the AVL tree.